Post-lab question number 2 asked to use Hess's law from the calculations of enthalpy using sodium hydroxide HCl and the NH3HCl reaction to calculate the enthalpy of this total reaction. So in order to solve this problem, we're going to take the enthalpy from the HCl NaOH reaction, which was right here, calculated that as about minus 63.2 kilojoules per mole in our experiment. And the other experiment was NH3 and HCl, so there's that. And in our 2 trials, we got an average delta H for this reaction of minus 38.4 kilojoules per mole. So the reactions that we measured the enthalpy of, and again, this is my data, your data may be a little bit different. The reactions for the NaOH HCl reaction, that's a neutralization reaction, is shown here. And then also the reaction for NH3HCl combo is shown here. So we calculated the delta H here, we calculated the delta H here. We somehow have to manipulate these 2 reactions using Hess's law to get this reaction here, the net reaction. So let's go ahead and write our first 2 reactions and also write our corresponding delta H's that we calculated from our lab. So I wrote down our reactions here and the corresponding enthalpy. Don't forget, for the neutralization reaction, we got about 63.2 kilojoules per mole. And for the second reaction here, we got a enthalpy of the reaction corresponding to minus 38.4 kilojoules per mole. So I wrote them down, and we want to get this reaction here, NaOH plus NH4Cl on the reactant side. So here we have NH4Cl on the product side. We want it on the reactant side, as you can see here. NaCl, NH3, and H2O should be on the product side. NaCl, H2O should be on the product side, and H2O liquid should be on the product side. So to me, to get this net equation that we're asked to find the enthalpy of, I think the strategy that I'm going to employ is to keep reaction 1 the same. So I'll call this reaction 1 and this reaction 2. I'm going to keep reaction 1 the same and then flip reaction 2. We're going to flip reaction 2. So when we flip reaction 2, the NH4Cl ammonium chloride goes on the reactant side, because that's what we want in our net equation that we want to compute the enthalpy for. You see here NH4Cl is on the reactant side. To get it on the reactant side, I flipped this equation that we calculated the enthalpy for in the lab. So flipping that, I'm going to flip the sign. This becomes endothermic now. Positive 38.4 kilojoules per mole. Let's add this to reaction 1. Remember, these are the values that I got. Your values are going to be slightly different because everyone's going to have different data. So let's add that to reaction 1. Totally untouched. So let me rewrite reaction 1. So leaving reaction 1 completely untouched, we can go ahead and add this together. And one thing that we notice immediately is that the HCl and the HCl, one is on the product side, the other is on the reactant side. They cancel each other out. Our net reaction now is going to be NH4Cl aqueous plus ammonium hydroxide aqueous gives us NH3, that's ammonia, plus sodium chloride aqueous plus water, liquid. Okay, water will always be liquid. And lo and behold, this exactly matches the enthalpy that we were supposed to find for, you can see it's a perfect match here to here. So we got that. To get the corresponding enthalpy, all we need to do is add them up together. So plus 38.4 minus the 63.2 gives us the answer for my data of about minus 24.8 kilojoules per mole. So this is how you're going to use Hess's law. Notice we calculated this and this from our lab. To get this, we had to just flip one of the reactions and add it to the corresponding reactions. When you flip the reaction, the delta H changes sign. So what was now exothermic here becomes endothermic there.